Hello everyone, my name is Vaibhav Shukla. I am pursuing my BTech in Information Technology branch from Institute of Engineering and Technology, Lucknow. Currently I am in second year and my eYRC theme name is Nirikshak Bot and our team ID is NB1305. Now I would like to introduce you with my teammates. Thank you.
Hello, this is Shikhar Gupta and I am a student of Institute of Engineering and Technology Lucknow pursuing BTech from IT branch second year.
My name is Kushagra Shukla. I am pursuing my BTech from Computer Science and Engineering. My college name is Institute of Engineering and Technology Lucknow, and right now I am in second year.
Hello, this is Devansh Shrestha pursuing BTech in Electronics and Instrumentation Engineering from Institute of Engineering and Technology, Lucknow.
Now I will elaborate about the interesting aspects and the various challenges we faced throughout the task execution. We perch on the brink of industrial revolution that is really mesmerizing. To interact with all the latest technologies we need to make sure we proceed by all possible cross checks and safety measures to avoid any calamity. To operate a highly non-linear platform with full accuracy and identify different aspects of controls, this theme flourishingly teaches us to do that and boost the mass production with quality assurance and within the stipulated time frame. 2 degree of freedom ball balancing platform, which is used for laboratorial purposes and also in automation systems, allows us to understand the image processing control system and algorithmic implementation of mechanical designs and much more. Now I will describe the challenges we faced across the theme. So one by one, let's discuss it. So the first challenge was strenuous and cumbersome start. When we started setting up the software to run the theme and understand new concepts of image processing or simulation, it was literally too difficult to move on. However, we continued and automatically things became clear as crystal. The second challenge was encoding of maze and modeling of a 2 degree of freedom ball balancing platform. To read the maze and encode it was really too tiring as we were not getting any hint like how to process the image and convert it into a matrix. But after more than 20 unsuccessful attempts, we somehow did that, and modeling of platform took more than a week of continuous efforts as to connect the things and understand Cochlear SIM interface hierarchy dynamics was also grueling. However, by referring to web and online resources, things became more clear. Moreover, we did a lot of experiments and fun in Cochlear SIM to model our platform. Third challenge we faced was PID. PID was beyond all the concepts that we learned till now. I accept to start a new topic is difficult and filled us with fatigue. But to understand PID equation for the first time was totally and absolutely beyond our imagination. Those integrals and derivatives terms seems like it is meant for someone highly skilled professors, not for students. Moreover, perfect tuning also took lot of time. But yet, after so many unsuccessful attempts and experiments on our servo, we understood the PID equation. Also, instead of turning back, we kept on working with full zeal and enthusiasm. Thank you.
So we begin by entering our team ID, then path of workspace, and then we choose configuration. So here bonus, and then we click on proceed. So we will look how simulation works, and this is executable app which has been developed by eYRC. So we will click on start and we can see the status as running. And now we will switch to our Cochlear SIM app, which is popularly known as VREP also. So this is what all about simulation, but now we will understand how this simulation work and what are the different things that we can see right now on the screen. What are they and how this traversal will actually take place. So one by one we will consider every aspect and its implementation and the different techniques that have been used. So in this scenario, we are having five balls and the aim is to drop all the balls one by one to their designated collection box. So we will discuss how this happened. But before I start with that, let me describe about the arena or the scene that we are having right now. So in this case, we are having four tables and these tables are nothing but ball balancing platform and they are used to balance the ball and travel the ball across the mazes. And let me describe the table names. So in the center we are having table 4, in front of it we are having table number 2, to the right of it we are having table number 3, and to the left of it we are having table number 1. Now, except table number 4, all the tables are having 3 collection box in which the ball have to be deposited by traversing through or by traversing across the mages. So let me describe the collection box name. For table number 3, in front of it we are having collection box number 2. To the right of it we are having collection box number 3, and to the left of it we are having collection box number 1. Now coming to the next table, that is table number 2. To the right of it we are having collection box number 3. To the left of it we are having collection box number 1, and in the front of it we are having collection box number 2. In the very same way, for table number 1, in the front of it we are having collection box number 2. To the right of it we are having collection box number 3, and to the left of it we are having collection box number 1. So we have seen about tables, collection box. Now let's look about the belt. So here, as we can see, that we are having a orange colored ball dispenser, and yes, this drops the ball at a regular period of 80 simulation second, and within that time frame we have to traverse the ball across the mages and deposit it into the right collection box. So table number 4 is connected with ball dispenser with the help of belt number 4. Similarly, belt 3 connects table 4 to table 3, belt 2 connects table 4 to table number 2, and belt 1 connects table number 4 to table number 1. So this was all about belt, and we have seen about table, ball dispenser and its property. Now let's look about the vision sensor. So in this case, we are actually capturing the ball image and decide its centroid, and using that we are controlling it. But how this is done? I mean, who actually captured that? So we are having vision sensor which are installed on the top of every table and on the belt number 4. So on the belt number 4 we are having a vision sensor which is named as vision sensor 5, and this vision sensor actually captures ball and then compare it color with JSON file in the Python script, and using suitable APIs we are able to transfer the data from Lua to Python or Python to Lua and then execute our code. So vision sensor 5 is used to detect ball color and helps us to find out collection box. Then if we talk about all other 4 vision sensors which are installed on the top of the table, then vision sensor 4 has been installed on table number 4. In the very same way, vision sensor 1, vision sensor 2 and vision sensor number 3 have been installed on table number 1, 2 and 3 respectively. And obviously they are used to capture ball position in the form of centroid, and yes, they are used for controlling it. So this was all about arena and its description. Now we will see how these mazes are drawn. As we can see on the table, we are having black colored lines. They are nothing but they are mazes and represents wall of the mazes. So how these mazes are drawn? So we are actually we are reading .png extension images of mazes, and then we are encoding it in 2D matrix, and finally we send the data to the Lua script, and here in this CopliaSim software we finally decode it and in the form of wall, and finally we use to draw the walls, and thus we are able to see that maze get generated on it as soon as simulation starts. Now, very important aspect, how this traversal actually is taking place. So all the ball balancing platform are having 2 servo motors assigned to it, and both servo motors help, or you can say they actually act as an actuator in our case, to balance the ball and help in the traversal. So what happens that we are having ball at some position and then we used to define its set point. So we are having some error in x and y direction respectively, and then we used to minimize that error with the help of PID equation. We use proportional integral and derivative gain simultaneously, and with the help of the combination of that, we are able to generate a specific angle for both the servos in x and y direction, and in this way the ball actually traverses its path. And here the servo which have been used is having 180 degree of freedom, of rotation freedom. So using that servo motor we are able to traverse the ball into the right direction. And we have considered a lot of factor, like ball should not overshoot, or it should not go to the dead end of these mazes or into some blocks, so that it may not get stuck. So this all have been achieved by a lot of tuning and effort. By tuning PID many times, we are able to successfully do this. Now, again, a very important aspect, that is how these paths are drawn. So obviously these are nothing but these are drawing lines of this co-PSM software, but still how we find out the path. So we have considered each cell of every table as a node, and then we have constructed suitable graph for it by connecting the nodes, or we can say the cells, which are having some path across it, right? So using BFS traversal technique, we are able to find out the path from one node to another, or we can say from one cell to another in our case. So using BFS traversal technique and proper algorithm of BFS traversal, and then we have crawled the path. So according to that we have constructed this path. Now, as right now in the scene we are able to see that one red ball have been deposited in the collection box number 1 of table 2. Similarly, one green ball have been deposited in collection box number 3 of table 1, and one blue colored ball have been deposited in table number 1 of in collection box number 1 of table 1. So still there are two balls left. Right now we are able to see that a red ball is traversing on table number 4 and it is about to be dropped on next table, that is table number 3, with the help of belt number 3. So we can see that ball is slowly and gradually traversing its path with the help of PID equation and various implementation that we have seen already. So we see that yes, the ball have been dropped on belt number 3, and finally it is going to drop on table number 3. Now as soon as it drops on table number 3, servo, or we can say hair actuator, start working and helps the ball to control its momentum kinetic energy in a very desired manner to traverse the ball in the right direction. So as we can see, the ball is traversing, and yes, we can see there are many sharp turns and blocks so that ball may not get into stuck. So that ball may not get stuck. That's why we have tuned a lot, so that it may not get stuck in some undesired manner. Now we are having last ball, that is a blue colored ball. So let's wait for that disc to come at 0 position or 0 count position of ball dispenser, and we will look the journey of this ball throughout the journey, like how actually things are happening with for every case. So let's wait for that. By that time we can see that this ball dispenser drops the ball at every 80 simulation second. So we have successfully dropped 4 balls out of 5, and this is the last ball that we are going to say, or that we are going to see. So let's wait for that. So the ball is slowly and gradually traversing, or we can say it is about to pass through belt number 4, and it will pass to table number 4 with the help of belt number 4 from the ball dispenser. So as soon as we can see this ball will pass through vision sensor number 5, its color and collection box will be detected and will be printed on the screen. So let's wait for the ball to come under vision sensor number 5. So we can see right now that ball have been dropped, yes, and we can see on the screen that blue T1 CB1 have been printed on our screen. Now here this blue describe its color, which is very obvious, as we can see on the screen that the ball is blue colored, and T1 CB1 describes its path, its collection box. So as it is T1 CB1, that's why we are able to see that blue colored path have been drawn on table number 4 up to table number 1, and the ball is traversing its path across it. Now the ball will travel and will be dropped on belt number 1 so that it can reach table number 1. So we will wait for that, so that ball get dropped on belt number 1. So yes, ball have been dropped successfully on table number 1. Not table number 1, it's belt number 1, and now it is dropped on table number 1. Okay, now as we have seen that the collection box was assigned for it was 1, that's why a blue colored path have been drawn from the entry point of table number 1 to the exit point of the collection box number 1. And again, using proper image processing and OpenCV library, we are able to detect the centroid location of this ball, and then we are continuously try to traverse it, and we are continuously trying to detect it images, process it, and then using PID equation we are sending proper angle or specific angle to servo X and servo Y so that it traverses into right manner. Now the ball is about to reach the end point and it will get deposited, and after that the simulation will stop. So the ball have been deposited successfully and we can see the scene have been stopped. Okay, so let's switch to our grader app. Yeah, so here we can see that we have a status of OK tested, which says that ball have successfully traversed its path, all 5 ball from 1 to 5, and we are having different scoring parameters. Okay, thank you.